the two choices, parallel activities, or we have a very high reliability of each component. Now what I've done here is I've taken the drive end bearing of the electric motor and turned it into what we call as a reliability block diagram. It's a process chain. I've said, okay, let's just take this section of the motor and say, okay, well, power comes through, there's a shaft journal involved, there's a shaft seal involved, there's a lock nut involved that keeps this thing working properly. If that lock nut comes off, we're going to have troubles with that shaft moving up and down. There's an inner race on our bearing. There's the lubrication, of course, between that inner race and the element. There's lubricant. We have a rolling element. In this case, it's a ball bearing. And again, we have lubricant on the ball bearing to the outer race. There's a housing bore. The housing's on the end cap's on the frame's on a base plate. You know, there's a whole chain here that I haven't actually put in there, but it's there. That might be, in the end, 50 components long. That fails, that goes down. This thing's driving my prize machine. This is the thing that drives the machine that makes money for the company. I'm out of production. If that goes down, same story. If that goes down, same story. So if I've got 100 of these things in line, any one of which goes down, my machine goes down, my process goes down, my business goes down, I have to watch out what causes these things to fail. And that's why we focus so much on part reliability in plant wellness. I've got to make sure each of these really, really high reliability. Lots of nines in a row, because that is the only way to ensure this thing will survive 25 years trouble-free. So now I've got to say, well, what can destroy, if this fails, and I'm down and it costs me $2 million a day, I can afford to pay for some maintenance. So now I've got to say, well, how can my lubrication fail? And we go back to our table of the way things can fail. We can say, well, here are 15 ways to destroy the lubrication. Let's make sure that none of those happen in this company. Let's introduce the best practices to prevent that from happening. So these best practices pay back because lubricant is now safe and in great condition. My lock nuts never come loose because we put them on right and we double check they're right and you make sure the thing is correct. My shafts are always straight, always in alignment. There's no banana bending because they're got a soft foot problem. So that's the whole point of having a reliability block diagram. I want to draw our machines like this. I want to draw our business process like this, because any one of those fail, the business is in trouble. So I want to begin asking, what can cause my rolling element to fail? What can cause my housing board to fail? Well, if that's machined incorrectly on day one, manufacturer made it out of round, then I've got to start controlling the manufacturer's quality control too. Now, one other thing this does for us, this is actually the DNA of your machine. If you draw a reliability block diagram of your whole machine, that's a string of its individual genes. Each item's like a gene on our DNA. So if I can draw my machines out with arrangements like this, it's just a process flow diagram. That's what it's just I call it a reliability block diagram, but it's just a process flow diagram, boxes and arrows. So I can say, well, gee, wherever I see this string of arrangements in any machine in my business, then whatever works for this particular arrangement will work for that machine and this machine. So in plant wellness, what we do is we have a look at one bearing. How do we ensure one bearing is highly reliable for 25 or 30 years? And then whenever I see a bearing, I'm going to do the same thing again and again and again. So I don't analyse every single machine in the plant. I analyse the assemblies. And whether the assemblies repeat, I just take that same solution into this new machine. So we try and do the analysis logically and as smart as possible. But the whole point is, once I draw my machine up like this, or my process up like this, or my production plant up like this, then I can begin saying what loses reliability, what will cause the problems. Where does the risk come from? How do I manage that risk? And then we put those things into play.